Thank you so much, and we will have some time at the end, and our next speaker is Professor Claudia Diaz, please.
All right. Well, hello everyone, and thank you, Michael, very much for the invitation, and thanks to the organizers. It's lovely to be here. So I'll be talking today about anonymity, which is one of the topics I've been dealing with in my research for a number of years. And I want to basically explain the main concepts and help you understand why achieving anonymity in technical systems is so challenging, more challenging than you would think in first instance. All right, so first of all, what does it mean to be anonymous? Anonymous is a word that comes from Greek, is the prefix ano, and the word onoma, and that means no name. So to be anonymous means to have no name. And in technical systems, how does this look like? So it could be that we have a subject that is present physically and we don't know their name, like for example, the fact that I'm Claudia, but that's not the only case. We could also be thinking of our anonymous subject could be the owner of a certain device or the owner of a certain Twitter account that we want to identify. It could be that we have a database with a number of records and our anonymous subject is the subject that is related to one of those records. It could be a subject that is making a transaction, such as a purchase, or the writer of an anonymous online text that we want to identify. So there are many possible subjects that we might want to name, and they take different shapes in different contexts. Now, again, the name that we want to attach to this subject, it can be different things. Obviously, what we think normally as names is like the name that people call you by. But this is not the only name that you might want to attach. There is, for example, ID numbers that are unique are also names. Maybe your biometric identifies you in a way, in the same way that a name would. Or in network, when we look at network layer anonymity, for example, we're very concerned with IP address as being the kind of the name that we want to hide in an anonymous system. Or it could be like, what is the cookie number in this database that gives me access to your prior history, right? So in this anonymity setting, what we want to have is this subject that we are not able to connect to the name. So a name is not just a name. Why names are important and why anonymity is important is that this name is connected to a history. There is a database, a prior history of actions, attributes, activities, relations, all kinds of information connected to that name. This is why preserving the subject, keeping the subject separated from the name is important. If the name was just connected to nothing, then it would not be very informative. But the name is important because it has all this history connected to it. So when we can name the person, we can not only put the name, but we can connect them to their prior history, and we can also add to this prior history whatever new thing this anonymous subject is doing to enrich this history. And in technical systems, when we think of anonymity, it's not either I know your name or I don't, a kind of binary. It's rather that we have a bag of names and we have a set of people and we want to see which name corresponds to which people. So you could think about it as a bit as having our badges, the badges of all the people in the room. That would be the names. We would have the people on the other hand, and the game would be to connect which name corresponds to which individual. Okay? So it's not about either I know it or I don't. It's how many people or how many names could possibly be the one that is correct one for this person. All right, so what does it mean to be anonymous in digital systems? The question is actually quite difficult to answer because it's very context dependent. So it depends on the anonymous action or subject. It depends on the sort of name, on the available background information that we have. Background information is not just background information, again. Here we can also analyze this background information to infer new things. So for example, if I know that if I have location information for you and I can see that every week you go twice to this clinic where they perform dialysis, I might be able to infer that you're a diabetic. So when I see a record of somebody who's a diabetic in a medical database, for example, I might be able to connect it to the location records, because these location records are going to these location points that correspond to a clinic with a pattern that corresponds to that of a diabetic person getting dialysis, right? So it's not just the raw data, it's also what analysis and inferences we can make from it that enrich our understanding of this data and might help us connect this name to the anonymous subject. So typically, in either data anonymization or anonymous access, this anonymous subject that is either having a record in their data set or is doing something in a system without revealing their name, typically we will have some leaked information. And this is really the key here, because this leaked information will give clues to help us connect, to help us name this anonymous subject. Okay? Oops, sorry. And of course, that depends very much on the threat model. So in privacy engineering, which is what I do, is very much coming from security engineering, and this is very much threat model based, in the sense that when we say that somebody is anonymous, anonymous towards whom? So this is anonymous towards some adversary with some capabilities that will not be able, that you want to design a system that prevents that adversary from de-anonymizing the subject, naming the subject. And very importantly, whenever you have a technical solution, security technology, privacy technology, you have to understand that any guarantees that this technology is provided are based on assumptions. So if the assumptions are not holding, your guarantees are gone. So it's always very important to keep in mind which assumptions are hidden in the technology and to check whether in your real scenario these assumptions are actually fulfilled. All right, so data anonymization, I want to talk about data anonymization on the one hand, and then I want to say a few words about anonymous online access. These are, of course, very much related, but they are not exactly the same thing. So to start with data anonymization, this is often seen as a kind of privacy panacea, because if we are able to really effectively anonymize data, then we can have open data, we can publish it for everyone to do analysis, then we can find all kinds of interesting information about populations, improve our systems, and so on. Also, for example, from the perspective of GDPR, if you're able to anonymize your data set, then the kind of provisions that you have to fulfill are actually lighter. So it's very interesting in that respect. Okay, but what does it mean, again, to be anonymous? And when can we tell that data has been anonymized? Article 29 published some guidelines on anonymization, and they gave 3 rules: that it should not be possible to single out an individual. That means that nobody should be unique. It should not be possible to link records relating to an individual. If you're in 2 databases, it should not be possible to connect these 2 records as belonging to the same person, or if there are 2 records in the same database, it should not be possible to connect them as belonging to the same person. And it should not be possible to infer information concerning an individual. Okay, so spoiler alert, this is actually extremely hard to achieve. If we have to achieve this, then probably we will not be able to meet the criteria in many, many cases. And the key point I want you to take from this is that, and I will try to prove it in the 3 examples that I'm having in the following slides, is that data anonymization is very much an open problem. It's extremely hard to solve, and we don't really have satisfactory solutions at the moment. All right, so why is it so hard? How hard could it be to be anonymous? So I will start with a very well-known old example from the 90s. When the Group Insurance Commission in Massachusetts decided to publish anonymized data records for researchers to be able to do analysis of medical information. So what they did, so the records that they had, they contained some demographic information such as zip code, date of birth, sex, and then medical information from the files. And they had been anonymized because they removed the name, right? So anonymous means no name. They took the name out, so everything should be fine, right? So meet our adversary as Latanya Sweeney, professor at Harvard, and the capabilities of this adversary was basically access to public information. So it was not that she had access to any specific secrets or any specific capabilities within the system. It was just public information. So what she did was that she purchased the voter list of the state. Now, this voter list had, again, demographic information, such as the zip code, date of birth, sex, plus other information, and also the name, because this was not an anonymized data set, okay? So we have here zip code, date of birth, and sex being in both data sets. Well, this, in principle, it shouldn't be so much of a problem because, I mean, well, sex, I mean, roughly half the people have, you know, one or the other. Dates of birth, there are many people that are born in the same day. Zip code, many people live in one zip code, right? So it shouldn't be such of a problem. Now, the problem here is that even though each of these attributes by itself is shared by many individuals, the combination of them becomes very quickly unique. And she found that for 87% of people, the combination of zip code, date of birth, and sex was unique. So basically that enables the de-anonymization. She actually de-anonymized the governor of the state to make her point, and his records then became kind of available, not anonymously, but with the name included. So the assumption that she broke here is that it's enough to remove unique identifiers. So it's not just about taking out the name. We have to do something more when we want to anonymize a data set. And she proposes as a solution k-anonymity that suppresses some of these fields, or some information we remove, and generalizes some other fields. So instead of the date of birth with the day, we may have just the year. Maybe that's enough for our purposes, and that, you know, makes it coarser. So this indeed raises the bar for the adversary. I will not go into the details about the problems, but it's still limited in the sense that it assumes that we know all the relevant information that will be available to the adversary. So in this case, we will know that the adversary will know zip code, date of birth, and sex. But what if the adversary also has some information about your prior medical treatments? I know you went to the doctor last year with a broken leg. What if I can identify that in the data set? This is not taken into account in this technique, and therefore it would still be possible to de-anonymize. Okay, you can say, well, zip code, date of birth, sex. I mean, that's kind of identifying. It's the kind of thing that is on your ID card, your passport. You can think that possibly that's, you know, kind of limiting your anonymity. So let me give you another example that makes the point even more clearly. Netflix released a few years ago a data set of movies, of records from their customers, again without a name, that just contain the movies that they had watched, at the dates, and the ratings. Okay? And they did this release of data for the purpose of improving their recommendation algorithms. It was kind of an open competition. People could, you know, play with recommendation algorithms, and this data set would help them check if their recommendations were good or not. And when, you know, in the FAQ, it said, okay, should people be concerned about privacy? Not at all. Everything is taken care of. It's completely anonymous. You don't have nothing to worry about. And, I mean, arguably, you cannot go to the census and purchase any such information, so it should be fine, or so we can think. So our adversaries here are Arvin Narayanan and Vitaly Shmatikov, and again, they also used access to public information. They didn't have any special insider information to conduct this attack. In this case, the public information was IMDb, which is another system where people can also introduce movies and rate them. And in this case, it does have a name because it has an account name associated with it. So it's not an anonymized data set. So here the issue was that if somebody had an account in both the Netflix anonymized data set and the IMDb identifiable data set, the movies that they would rate would be the movies that they have seen, and they would have been within a certain date range. And normally, if they said the movie was fantastic in one system, they probably don't say that the movie is horrible in the other system, so the ratings should also be correlated. Okay? And the issue here is that there are millions of movies. People have seen typically 10, 20, 30. The combination of which movies you have seen very quickly becomes unique. So it becomes like an identifier because nobody has seen this movie on this date, and this movie on this date, and this movie on this date, and so on. So basically, because this is such a sparse and big space, and each person in this space is very far from each other, they are very unique, and they are very identifiable, and when you do not confuse one person with the next if they are in both data sets. So here, the assumption that they break is that a simple list of items and preferences is not identifying of the user who generated them. We don't need to have even demographic information. Even data sets that in principle don't have what you would think of personal data as kind of a more straightforward type of data is still not anonymous. And third, final example regards location. And again here, mobility traces are highly unique. This is work by Yves Alexandre de Montjoie. And he showed with telecom data that was actually quite rough. It was the hourly temporal resolution. and the spatial resolution was the carrier antennas, which is pretty big areas. And even with these data sets, he shows that 4 points are enough to uniquely identify 95% of individuals. So if I know the hotel you're staying, and I can have a point that you were there during the night, and I know now you're here, and then I know where you go for lunch, and then where you go for dinner in the evening, and I'm able to see that in the data set, that would probably be unique to you. And then that means that I'm able to very easily identify people. Again, here, the problem is huge universe of combinations, sparsity, and uniqueness. In the previous case, it was overlap between two data sets that are related. In this case, there is only one data set, but we have a persistent behavior in time that becomes very identifiable, even if we add noise. This has huge implications for smart cities and IoT and all kinds of systems where location is either implicitly or explicitly used or revealed. Okay, so that was for data anonymity. In data anonymity, you are not really part of the system. Your data is part of the system. You gave it at a certain point in time, and now somebody's doing things with the data set, and they want to extract value from it, and they want to anonymize it in order to protect you. But what about you taking action online and wanting to be anonymous? It's a little bit of a different setting. So we have Alice. She's using the internet to access some service, and she wants to be anonymous towards that service, so that the website, for example, that she's visiting doesn't know that the person visiting is Alice. Okay. So in the classical way in which we model secure communications is this kind of picture here, where we have Alice talking to Bob over some channel, and we want this channel to be confidential, authenticated, and integrity protected. And we have an adversary Eve that can eavesdrop on this channel, maybe modify messages on this channel, and will try to break these properties. Now, the problem here, if we want to extend this model to also account for anonymity, is that we cannot model anonymity in this kind of picture, because the adversary sees that Alice is already talking to Bob, so it's game over already from the picture before we even start, right? So if we want to have a model of how anonymous communication looks like, we need to have many Alices and many Bobs, okay? And adversary now is a bit more complicated. It might be parts of the system, because this cloud in the middle will typically have many intermediaries. So maybe some of these intermediaries are adversarial. Maybe some of the Alices or some of the Bobs are also adversarial. Okay? So the key point here that I want to make is that you cannot be anonymous on your own. Okay? Anonymity means that you're hidden in a crowd of people. I go back to the bag of names and badges. Okay? So you will be more anonymous if there is a bigger crowd that you're hiding with, and less anonymous if there's a smaller crowd you're hiding with. But it's not something you can achieve on your own. Of course, you want this crowd not only to be big, but you want it to be diverse. The more diverse this crowd is, the more protected you are. As an example, imagine a policeman that is using an anonymous communication system to conduct an undercover investigation, going to some criminal forum, for example, right? If I don't know, I might not know that this is, policeman, whatever, Jimmy Smith, but if I know that this is a system used by law enforcement, and whoever uses the system is a policeman, this is not an anonymity set that is very meaningful in protecting what the user in this case wants to protect, right? Because you also not only want to protect sometimes the identity, but also which groups you belong to. So the more groups you have, the more diversity you have, the more effective cover you have. And then the final point I want to make is that what kind of information leakage can we have in this kind of system, right? So maybe I can identify you because your phone has an antenna with a specific radio fingerprint, and that is identifiable, so when I see you in different places, I can see that you're the same person. Or maybe I can identify you via your network IP, or via the fonts that are installed in your device that mean that your device has a unique software fingerprint. Or maybe even if all of that is very protected, you are publishing something anonymously online, but you have a writing style that is very distinctive, and I can therefore identify you via your writing style. Or maybe other behavioral data, okay? The point I want to make here is that the leakage that enables the anonymization can occur at multiple layers. Anonymity is very fragile. When you have an anonymity solution, typically you are operating on one or two of these layers. So for example, the Tor system, for those of you who know it, it hides your network IP and it does quite a bit to protect your device and software fingerprint. But if you use Tor to publish an anonymous text online and you have an extremely distinctive writing style, you will be probably de-anonymizing yourself via that vector, okay? Or even if you're there are all kinds of leakages and all kinds of levels that can give away your identity. Okay, so coming to the conclusions, anonymity in ICT context is very hard to achieve. This is because of uniqueness. We are very quickly, because we have so many attributes, so many data points, it's very difficult to confuse one person with the next, which is what you need for anonymity. So behavior, location, preferences, all of this can give us away. We have vast amounts of available data and memory. This is the prior information we have connected to names that help us find clues in your current activity that might de-anonymize you. And we also have this massive computing power that means that we can do a lot of we can make a lot of inferences that enable us to do linking, probabilistic linking, to probabilistically re-identify people. In terms of data anonymity, when you hear that, okay, we have this data set, but it has been anonymized, so it's all fine, take it with a big grain of salt. Because typically this will be based on very restrictive assumptions, and it will be probably not very strong anonymity once you look into it. So if somebody is trying to tell you that a data set is anonymized, ask more questions. What's your adversary? What are your assumptions? What kind of information is still contained there? And accessing anonymous online services requires that you blend with a crowd of ideally diverse people and that you take care of protection at multiple layers. And even then, it's often an arms race because, well, it's kind of like security that you have attacks and defenses competing. And it's still very much work in progress, I think, to have strong systems that can deliver on these promises. Thank you very much.